Here is a doorstop, which is composed of a wedge and a cube behind it. The cube part is 5 centimeters by 5 by 5. The wedge, of course, is also 5 centimeters tall, and let's just say that the triangle that it's built on is 12 centimeters and 13 centimeters on the hypotenuse. What is the surface area of the doorstop? One way to look at this is to imagine the cube separately, floating in space with its 6 faces, and calculate the surface area of that. Imagine the doorstop separately, calculate the surface area of that, and then subtract the areas that are covered by the contact. There are other ways to do this, but let's have a look at it this way. Since the cube has the dimensions of 5 by 5, on each face it's 5 times 5. That's the area of one face. It's got 6 faces times 6 is 25 times 6, or 150 centimeters squared. This area in yellow is the contact area, and we can subtract that out. So the contact area is just one face, which is 5 by 5, the yellow face, which is 25. So the surface area of the cube is 125 centimeters squared. There it is. Now let's have a look at the wedge. Here's the wedge with the measurements put into it. Now I might make a net of this and it would work fine, or I think this time just for fun I'll work with a 3D object. The area of the bottom, which is the area in green, is equal to 12 times 5, which is 60 centimeters squared. The area of the slope is 5 by 13, or 13 by 5, it's all the same, which is 65 centimeters squared. The back of the wedge is 5 by 5, or 25. And finally, the area of the two triangular sides is, it's a triangle, it's 1/2 the base, which is 12, times the height, which is 5, and there's 2 of them, times 2, which is 60. Okay, let's make a little more room here. Well, these all add up to the surface area of the wedge. This wedge, if it were floating in space, all sides visible would be the bottom, plus the slope, and the back, and the 2 triangular sides. And I get 210 centimeters squared for that. Now the region in contact with the cube is the back side right here, and that is 5 by 5, or 25. 5 times 5, which is 25. We have to subtract that out. So the surface area of the wedge, after we've subtracted out the contact point, is 210 minus 25, which is 185 centimeters squared. There, I had to shrink it again. Okay, here we are. The surface area of the wedge is the surface area of the cube that is not lost by being in touch with the wedge, plus the surface area of the wedge itself minus the area lost because it's touching the box. So that simply is the surface area of the doorstop is equal to 125 centimeters squared plus 185 centimeters squared. 125 plus 185, which is equal to 310 centimeters squared. Now there are other ways to do this. For example, we could simply have made a net. If that's what you would like to have done, no problem. Here's one way to have drawn the net, and here's how you might have added them all up. And of course, it does equal the same value, 310 centimeters squared. Please try guided practice for lesson 6, or if you would like a little bit more background, please look at the videos, what is meant by a composite object, and surface area and surfaces that touch. Thanks very much.